In example 2, we're looking at a truck that is braking while it goes downhill. And you've probably heard of this before, but brakes heat up. So big trucks have to be very careful. If they heat up the brakes too high, then they won't be able to brake anymore. So a student decides to do an experiment here, and if we look at the given information, we see that he finds that there's 10 joules of thermal energy that is created, I guess, from braking. And it raises the temperature of the 5 kilogram, I'm assuming this is disc brakes, from a temperature of 21 to 37 Celsius. All right, so let's write down the given for that initial scenario. Q initially is just 10 kilojoules. The mass is 5 kilograms. And the change in temperature is, well, 37 degrees Celsius minus 21 degrees Celsius. Okay, and then we want to know if we had the same material disc brakes, but they were, I guess, larger. They had a mass of 15 kilograms, and then they were only raised up 4 degrees, then how much energy would be required? So the new mass, I'll call it, I guess, M primed, is 15 kilograms, and the change in temperature in the new scenario is going to be 44 degrees Celsius minus 40 degrees Celsius, so basically 4. Okay, so what we're looking for is the new heat that would be required. So there are a couple ways to solve this. You do it probably in ratios if you'd like, or you could just calculate things. You could say, well, I don't know the specific heat of this substance. So if you recall, this is a specific heat formula. We want to look for the heat capacity. That's that value C. So the heat capacity of this material would be the heat divided by mass multiplied by delta T. So that's 10. Well, we could change it to joules. I'll just leave it in kilojoules just because I see the answer here is in kilojoules anyway. 10 kilojoules, and the mass is 5 kilograms. And the change in temperature is, that's 16 degrees Celsius, right? 16. So that gives us a specific heat of 0.125 kilojoules per kilogram times degrees Celsius. So now the new heat would be the new mass, the same substance, so same heat capacity, multiplied by the new change in temperature. So this new heat would be 15 kilograms multiplied by 0.125 kilojoules over kilograms times degrees Celsius times a change in temperature of 4 degrees Celsius. So this new heat will be 7.5 kilojoules. By the way, just if you want maybe a faster way, you could probably just do this as ratios. You could probably say that the specific heat is the same, right? So you could say that this guy is the same, right? So you could say that Q over M delta T initial is equal to Q prime all over M prime times delta T prime. And then you could substitute your numbers in and then essentially solve for the unknown, which would be Q prime. That's another way of doing it. Yep, hope that makes sense.